Everybody, I cordially welcome you to this talk with the title Line and Hemisphere, a hybrid spatial studio setup at the University of Arts and Design in Karlsruhe. I am very happy to have received this opportunity to display our research and work at the State University of Arts and Design in Karlsruhe in Germany. My presentation is structured as follows. First, I introduce to the motivation of our work and give some examples of previous research and projects we have undertaken. Then I display our project, which is to combine a wave field synthesis system with a spherical speaker setup for high-order ambisonics. For this, I first report about the making of a do-it-yourself wave field synthesis system, followed by the description of the spherical loudspeaker setup which we use for this project. I will conclude this presentation by summarizing the displayed material and give an outlook for future work. Our previous works were based on the project Speaker Heard. This project is based on a mid-number of loudspeakers, about 50, with high-quality audio. The idea was to provide the environment for flexible experiments in spatialization. For this, we wanted to achieve conventional and unconventional speaker setups. Conventional setups such as stereo, surround, vector-based amplitude panning, ambisonics, high-order ambisonics, wave-field synthesis systems, and use spatialization software appropriate for all of these setups, such as the IEM suite, Here Comes SPAD objects, the ZHDK projects, or entire tools such as panoramics. We wanted to be able to apply flexible programming using MaxMSP, Pure Data, Super Collider, Reaper, Pro Tools, Nuendo Ableton, or any other environment or digital audio workstation. Furthermore, unconventional speaker architectures we wanted to experiment with. One of our first setups was a spherical architecture. This was done with 7 rings, 1 speaker at the bottom, 4 speakers in the next ring, 8 speakers in the following, and in ear height 12 speakers, followed again by 8 speakers, 4 and on the top 1 speaker, which are in total 36 speakers, and additional on the bottom 2 subwoofers. With these 36 speakers, a 5th order, high order ambisonic decoding was achievable. A complete different setup was the Hörgang, a parallel setup where 2 lines of speakers, each speaker about a meter distant from the other. These speakers were hanging from the ceiling, and the audience was meant to walk through these 2 lines and receive the music and the sound pieces. The cone setup, tree or Baum in German, was a setup which was aimed to project audio into larger halls. It was constructed as a row of diminishing rings from the bottom to the top. With Untitled 3, a piece by Anthony Mayet, we were able to realize a mixed setup where different ambisonic and vector-based amplitude panning modules were combined in a larger hall. Untitled 3 of Tony Mayet can be seen as very closely related to a later artwork, The Morning Line by Matthew Ritchie, which is combined with architecture and audio architecture by Tony Mayet. This piece also provides a range of different audio spaces. The multispatial speaker setup of The Morning Line is composed out of 6 different spatial rooms, acoustic rooms with various spatialization technologies. To experiment with different audio projection techniques, we set up the speakers as a wave field synthesis system. The speakers have a range of 41 Hz to 22 kHz, and setting them up in distances of about 23 centimeters, we gained a resolution for the wave field synthesis effect of up to 3 kHz. The wave field synthesis is based on the Huygens-Fresnel principle and was developed and described by Berkut in Delft 1988. It is possible to reproduce exact waveforms for sources which are behind the speakers. Each point of a wavefront can be seen as a source of a new elementary wave, as you see here in these images. But also sources in front of the speakers can be reproduced using wave field synthesis. This is accomplished by using beamforming and applying proper filtering and spatial and time delay to the speaker array. In this image, you see the sound pressure level of a focused source created by beamforming using a speaker array with 10 elements, 10 speakers. To achieve a larger area for the audience, we used a larger line array based on the WFS system of IRCAM, which is built of Amadeus PMX5 units. These units are about 13 centimeter wide, extending the range of WFS reproduction to up to 4 kHz. This larger array of speakers for the wave field synthesis system we set up in our large hall combined with a ring of audio speakers. With this, we experimented on a hybrid system combined out of this WFS and the ring using ambisonics, as well as room simulation software and spatial reflections. Based on previous projects and experiments, the motivation to establish a hybrid studio setup was based on a row of topics we wanted to address. A major goal was the integration of different spatialization systems for audio and music creation. This would lead to extend the combination of audio projection techniques such as wave field synthesis and or high order ambisonics and or vector-based amplitude panning or other techniques which are used or can be used for audio projection. A goal was to get experience for spatialization techniques concerning the creative needs and possibilities and the software and hardware features required to achieve these creative needs and possibilities. We wanted to stabilize the working environment, and this led to a feasibility study of how to set up such a hybrid studio in a restricted environment about facilities and resources. The goal was to use material at hand and or to only use low-cost material and devices. A major topic in these thoughts are about immersion. So what is immersion? If you look to Wikipedia, which says Latin immersio, to dive into, to embed into, to be fully surrounded by, the questions arise: who dives into what? Who is embedded by what? Who is surrounded by what? A range of different three-dimensional audio-based conventional speaker setups address this issue. The aim of these conventional speaker setups are recreate a given recorded or mixed spatial sound scene. The approach is to mix or decode into a row of loudspeakers, and the result should be the recreation of an acoustic space, more or less with the background of hiding the speakers as sound sources. These considerations about acoustic projection techniques as well as immersion and all the motivation goals we had in mind, we thought about the design issues for our experimental environment for wavefield synthesis and ambisonics. So we decided to construct the wavefield synthesis system as a horizontal line array, following quite a number of approaches which already had been tested and used. The ambisonics environment should be a hemispheric grid to allow high-order ambisonics to be realized on this grid. All this only could be done in a small size standard classroom, about 6 meters by 6 meters. We expected to not be able to apply a special acoustic treatment, and we wanted to use available devices and technique for the ambisonics grid, which we thought to use from the project Speaker Heard, which are Genelec 8040's active units. For the WFS, we thought to use the possibility for a do-it-yourself project to realize the speaker cabinets and the amplifiers with the student project. For the audio interfaces, we thought to use the Mo2422 PCIe system, which at that time already more or less were outdated, but still offered a high number of audio channels for a low amount of money. For the technical realization of the wavefield synthesis, we used a Visotone full range speaker. The recommended volume of the speaker housing is about 10 liter for a closed cabinet, which gives a cutoff frequency at 103 Hertz, or for a larger 20 liter housing 91 Hertz. So we decided to go for a 10 liter per speaker cabinet, and which we tried to get realized in boxes 13 centimeters by 13 centimeters by 65 centimeters in dimensions. One topic we had to think of was the cable connection. Because with a high number of speakers, we will get quite a number of cable connections. So we can think of fixed soldered, clamped, or the CPC multi-connectors. For the first tests, we used a soldered approach, then to the clamped, and later we wanted to go to CPC multi-connectors to enable a fast setup of the cabinets. For the connection, we thought of using standard, which means low-cost twin cables. Here, a first drawing of the cabinet we thought of, and we thought of putting 8 speakers in one larger cabinet, in one larger housing, each speaker with a separate volume. A precise computer-aided design construction then gave the possibility to construct the speaker housings in such a way that a horizontal and a vertical stacking was possible. We see this here in the upper image. The cabinets are stacked vertically and below horizontally. This is first setup in a horizontal line to test the acoustic possibilities of the system. With this layout of the multi-channel cabinet, the distance between 2 speakers is about 14 centimeters, and the overall height of the cabinet about 67 centimeters. The 14 centimeters distance gives a frequency resolution of about 2500 Hertz. Each single cabinet for one speaker is about 10 liters as displayed before. Here we have a look into the removable front cover of the speakers, which enable a vertical and horizontal stacking of the speakers, as well as a close positioning of the whole cabinet to a wall. The speakers are Visotone WS13E 8 ohms, and they are full range. They are full range speakers. And here is the frequency response for the speakers. They go more or less up to 8 kilohertz, and above that they fall in their frequency reproduction. To examine the frequency response of the cabinets together with the speakers, we used the EarCam impulse response measurement object SPAT5 SMK with sine chirps about 0.6 seconds in duration. We recorded a single WFS speaker unit in about 1 meter distance. The result shows a gap at about 7 kilohertz and a peak at about 8 kilohertz. This can be equalized by an appropriate filter. To countercheck, we applied a phonic frequency measurement device in 1 meter distance with pink noise, a PAA3. What we see is, and in comparison here, the equalized frequency response measured by a PAA3 unit. The whole system was set up at Klingt Gut Festival in Hamburg, as you see, close to the wall, and in a combination with an ambisonics playback system with 8 speakers. The multi-channel speaker cabinets need multi-channel amplifiers. So to get those, we were looking for a good price relation. We wanted to have a good audio quality, and we wanted to integrate the multi-channel amplifiers into a compact size housing. We wanted to achieve a low to mid number of channels in do-it-yourself manner, and all that to realize in a student project. For this, we choose a project with Class T amplifiers, digital amplifiers, based on the TAA 4100A chip, which is a 4-channel audio chip at about 100 watts and 4 ohm. For this approach, we could use a ready design provided by 41 Hertz, which offers a small-sized layout with the TAA. 4 of these boards we could integrate in a 19-inch rack at 2 inches height, which gives in a total 16 channels output. As you see here, we had in the first approach these clamped outputs. 3 of these 16 audio channels units are mounted here in a rack, giving together a number of 48 WFS channels. Here you see the three amplifier units together with the audio interfaces, which are on top of the amplifier unit. The audio interfaces are based on two Motu 24 IOs giving 2 times 24 analog outs and one Motu 2408 to be able to address through an ADAT interface the AES subwoofers. In this image you see the setup speaker cabinets close to the wall, and in front of these WFS speakers you see the Genelec 8040s for the ambisonics and high order ambisonics grid. As a second audio projection environment, we wanted to establish a hemispherical speaker grid. For that we used a range of speakers and audio interfaces. 29 Genelec 8040s were used, plus 2 Genelec subwoofers, which are AES subwoofers. For the audio interfaces, we used one Motu 24 IO and one Motu 2408, giving us the access to 8 analog outputs and 2 ADATs, where we could use one ADAT output to connect it to an RME 8040D to convert the ADAT to the AES. With this setup, we could operate the hemispherical speaker with ambisonics, high order ambisonics, and other specialization techniques. Here you see a top view of a CAD drawing of the 29 speaker grid and the 2 Genelec subwoofers. The overall dimensions of the room are about 5.80 meters and 3.20 meters in height. Here the top view 5.9 by 5.9 with the speakers of the base layout and the other Genelecs. The speaker's circular distribution was accomplished by 3 rings and one top speaker. The lowest ring contained the largest number of speakers. The speaker's positions in the azimuth you can see in this image. For the first ring with 16 units, 2 speakers have an angle of about 22.5 degrees. For the second ring with 8 units, the angle between 2 speakers is 45 degrees. And for the third ring with 4 speakers, 90 degrees is the angle between 2 units. The angle for the WFS system is about 44 degrees, giving more or less an angle for the whole WFS of 90 degrees. Due to the room constraints, in particular the reduced height of the room, the distances of the speakers to the room center have to be adjusted. So the maximum radius has the lowest ring, which is about 2.6 meters from the director's point in the middle of the room. The second ring has a distance of about 2.4 meters for each speaker to the director's position. The third ring about 2.17 meters, and the top speaker about 2.2 meters distance from the director's position. This is also reflected in the different angles between speakers of these four rings. The angle between ring 1, the lowest, and the next is about 27 degrees. From the second ring to the third, 26 degrees, and the third ring to the top speaker about 37 degrees, adding up in total to 90 degrees. The speakers of the wavefield synthesis system are about 1.54 meters in height. It is above the director's position, but due to the channel lag position, this height had to be chosen. The overall room reverberation was measured with a SPAD5 SMK object with a sine chirp of about 650 milliseconds. It was recorded with a Neumann KM183 and with 2.5 meter distance to the channel lag 8040s. A comparative measurement was done with a PAA3 unit, also in 2.5 meters distance, using a sine wave as an exciter. And as you see, similar results for the room reflection. Here you see the hybrid setup in CAD drawing as a movie, which gives you an impression on the position of the speaker grid in a hemispheric setup. To operate the system, we use quite a range of software. For a flexible programming environment, we used Macs in different versions, as well as Pure Data or Super Collider. In special, we used IRCAM's SPAD objects for the hemispheric grid, as well as for the wavefield synthesis system. For the grid, we applied ambisonics, high-order ambisonics, vector-based amplitude panning, and other diffusion techniques. We applied also room simulation with a SPAD reverberator, and later with a SPAD5 object, we applied SPAD for the wavefield synthesis system. Other software like the ICSD ambisonic plugins, the IEM ambisonic suite, and others were also used on the system with success. We can see that WFS and high-order ambisonics can be achieved using one max instance, but to reduce the CPU workload, it is advisable for us to use WFS and high-order ambisonics on separate max instance, connecting them via jack or Soundflower and open sound control. This approach can be extended to divide WFS and high-order ambisonics on separate CPUs, connecting them via Dante, for example, and again, open sound control. Various digital audio workstation software we applied, such as Reaper, Live, and Nuendo, but also others. Here we see a max SPAD patch for the high order ambisonics grid, and we use quite frequently, according for the formula for the order of high order ambisonics, a fifth order coding for 36 speakers, which then are decoded into the 29 speakers of the real grid. These 29 speakers are a larger number of speakers than the 25, which would be for the fourth order. So the idea was to decode a fifth order onto the 29 speakers of the grid. Here we have a max patch for the WFS system, and we decoded the sources to the wave field system for 5 of our 8 speakers cabinet by omitting the upper and lower 4 channels of the system. I'm coming to my results and conclusions. What did we achieve? We showed that the combination of WFS and ambisonics can be done with reasonable effort. With this, different audio projection techniques can be achieved, and they result in different perceptive phenomena. Focused sources, for example, of the WFS system increase close-up perception of audio sources, especially by moving sources. Ambisonics and WFS expand in general the tools for immersive audio and music creation. The do-it-yourself approach of making a multi-channel speaker system is relatively fast and uncomplicated. The do-it-yourself approach of a multi-channel amplification environment is possible but much more time-consuming and error-resilient, in particular for unexperienced or non-experts. For an outlook are listed a number of items. Desirable is a closer integration of the timeline composition tool, such as digital audio workstations such as Nuendo, Live, Pro Tools, Reaper, with the acoustic projection tool such as SPAD, Panoramics, ICST Suite or others. Up to now, the connection of these two systems may be tedious and resilient to errors. Another goal is to extend the WFS to cover further walls. For example, to set up an L architecture, a U form or a full rectangle. In particular, for such setups, audio and acoustic measurements and tests are recommendable to investigate the relation between the high-order ambisonic projection and the WFS projection. Another goal could be to increase the spatial resolution of WFS, which would mean to add more speakers or to increase the number of speakers per meter. A more practical thing would be to replace all clamp or solder connections with CPC connectors and provide long multi-channel speaker cables. I would like to thank the audience for their attention and say goodbye. Thanks a lot.
Well, good afternoon. Hello, good afternoon. Do you hear me?
Yes, perfectly, perfectly. Thank you so much for a most stimulating presentation and for making time to speak with us. I know that you and you're very busy, so thanks for that. You can see in the chat that there are a few questions. So this time around, we shall start with those questions, and then if we have time, I'd like to put a few to you as well. So the first question in the chat reads, what do you recommend is a good way for composers to write spatial music without having access to such a speaker setup as you've just described?
Well, I would say it is difficult because um, in reality, nothing can really replace the room and the speaker combination um, in which a performance will happen. My experience is that even for very, let's say, high fidelity or very good um, environments like the ZKM dome, which is in the later um, questions named, it is very important to rehearse there. Yeah, at least to rehearse and adapt the composition to really the environment. Yeah. Um, but there are good workarounds which help definitely, which is a binaural environment. Yeah. So that the spatial information is mapped to a binaural playback. Yeah. You can try to make it good to by getting your own binaural information and integrate it or import it into the system to play it back. But also, let's say, standard binaural playback like the Kima functions. It depends on your ears, definitely. You know, it may work brilliant, but it may fail totally. Yeah. So that is, I would say, the workaround. Um, Also, what it helps to reduce to do the composition in a reduced environment, such something like a setup with only 8 channels. Yeah, 6 is the minimum. Ambisonics says you should use, but I think that helps definitely also. Try to do a rehearsal in a space most similar as in the performance. And coming back to what I said in the beginning, um, uh, there is no composition which is really functioning in every space. I would bet. I had a big argue with one of the ZKM sound engineers about that, but I would still say on this, it really depends on the space.
Right, right. I think you mentioned a very important issue or point, namely, essentially, you can only really compose in the space in which you're going to be playing back. And that's a luxury we don't have, you know. So it is a compromise all way around. I'm going to skip one question, or I'm going to skip two questions. And the last question reads, have you had experience with Super Collider Ambisonics Toolkit, with the Super Collider Ambisonics Toolkit?
To be honest, not really. Yeah. I named Super Collider in software which we were using on the system.
Yeah.
Yes, we did, but with the Ambisonics toolkit, no.
Uh-huh.
But I would say it shouldn't make a big difference to other good toolkits. Yeah, we quite often used recently, as I wrote in the presentation, the SPAT environment. Um, this is in some way very flexible because you have binaural playback. You can load your own
Yeah.
binaural information. You have various kinds of decoding possibilities, but it is also in some way restricted to a very analytical idea, yeah, which means, for example, you put the real room coordinates into the system, and if the room changes, what I said before, you know, then you have to change everything, and things getting different. So this may be a problem to try to be too analytical, too exact. Yeah.
Yes, you know, I think just something simple like you can't predict the number of audience members in a performance, you know, vis-a-vis rehearsal. So that already absorbs more energy.
Well, let's say it like this. The ambisonics idea is a totally good idea. And in a lot of situation functions, but in the end, it is a model of perception and a model. Well, perception, yeah, in some way perception too, but a model of acoustic projection. And in the end, what I said, yeah, a model of perception. And this is it is only a model. If you say ambisonics does do the whole reality, I have to argue no.
Yeah.
Recording, I would really agree much more, because if you do record with a high order ambisonics microphone, you get a lot of information. Yeah, and this is really, that is also our experience with the Eigen mic, with the ambisonics recording. This is really a, a real difference, yeah, between a sound feel and something like a microphone with 32 capsules or even more.
Yeah.
But in the playback, to really reproduce a recording or generate a composition in a really particular way, then other physical constraints and physical effects come into play. You know, because you do it in a room, and ambisonics is meant not to have a room in some way. And you have reflections, you have phasing differences, you have audience, as Theo said, and all that. And normally, the speakers are not set up in a proper sphere. What ambisonic says, you have delay compensation, you have ear compensation, all that. But all these are models. And as I said, my experience is, I heard several compositions where there had been no rehearsals from a good studio, yeah, multi-channel studio, let's say with 16 speakers, and going to a large performance hall with 44 speakers, and it was, let's say, it could be much improved, the performance, by adapting the trajectories and the relations of the moving sources and things like this. So maybe someone else would go against me and say, okay, if you do this, but I have to say this is the experience, and I said, okay, this is based on the still model situation of ambisonics or other playback strategies.
Yeah, yeah. I have a little technical question. When we go back to the beginning of your presentation, when you spoke about testing the frequency response of individual loudspeakers, you used a chirp signal. Is there any advantage to using a chirp versus a sweep as a test signal?
Well, but now in some way it's the same. I would say it's the same thing. The chirp is a condensed version. If you do something like a long-lasting sweep, you may end up in influences. I mean, a chirp is very short, so this is maybe the thing. It's a sweep which is quite very short, and so you have a frequency response which is condensed in a short time. Yeah. In some way, I would say this makes the situation less error resilient. You may get maybe reflection phase problems, which may be cancelled out in long sweeps. But I would argue that the chirp version, especially when you repeat them and so get something like a statistical measurement,
Sure.
I would say preferable
Right.
as to have something like a long ongoing sweep, if I understood you, Theo, properly.
Yeah. No, absolutely spot on. That is exactly what I meant. Last, I'm terribly sorry, but we have you here, so I have to ask you now. we can't let you go. Your university has now presented this, shall we say, playback system. It's it's adaptable, and it's been tested, so it's very stable. May I ask you to say just one or two words about the actual compositions that have been performed in this environment, please?
Well, yeah, to be honest, also what is quite, let's say, often used or continuously used is the ambisonics, yeah, and actually the mixture of ambisonics and let's say and vector-based amplitude panning, you know, so that the immersive character of ambisonics is used for immersive environments, something like reverb, sounds, and things which really touch more distant, immersive, let's say it like this. And reverb for localize sources really in one situation. So Dowie made a very nice piece about that, and she was using it because she really it is audio-visual work, so that at certain points she really wanted this cue, this visual and the audio cue from that position. And so he really preferred to use then the vector-based amplitude panning so that the energy of this audio event only comes from this position, really also in space. So this, the wave field, I have to say, because it's tricky to operate and the effect is special. We had a composition which also in the end was created. It was performed then at MPEG with Marco, but it is more tedious to get it to work, and also the effect is very special, and we don't had too many up to now too many compositions of that. And for the wave field, we don't have a binaural projection technique for the ambisonics and VBAP. More or less every good system does a binaural stereo rendering, so that you can work on your computer at home without the system, then go into the studio. And for the wave field, difficult. For that is also during the Corona time, it was a little bit already sleeping. Yeah, we have to get it to work again. And I have to say also this whole discussion about wave field is a bit coming down or cooled down, so that the high, hot people coming here now I want to work on it got fewer.
I see. Thank you so much, and we look forward to speaking soon.
Okay, and I have to thank you, Theo, and both Electrons, and apologizes for my that I couldn't be so present, and my technical problems too.
No, all good. Take care.
Thanks, and all the best to South Africa and Cape Town and UCT.
Cool. Thanks, man.
Bye.